What's up, everybody? Today we're going to learn multiplication of exponents, and we're going to be moving into the second unit here on online learning. So we're moving past the systems of equations. Make sure to get that done. If you have any questions, please ask. But now we're going to move on to the multiplication of exponents and really all exponent properties. So remember, an exponent, you have a base and then an exponent, okay? And if you want more details on, the fundamentals of exponents, you can look around for that stuff. But we're going to move past that into the properties of exponents, and more importantly today, the multiplication properties of exponents. So the EQ today is how can I multiply exponents? Okay. So what we're going to do first is we're going to write out the expression 2 to the power of 3 times 2 to the power of 4 equals 2/7. Okay. So 2 to the power of 3 is 2 times 2 times 2, okay? And then we're going to multiply it by 2 times 2 times 2 times 2, okay? So you've got 3 here and 4 here. Okay, we're multiplying. Now, we're going to talk about the property. The property of this is, okay, the A, this is your base, A to the M times A to the N, okay, equals A to the M plus N. So if A is your base, okay, and M and N are your exponents, you're going to add them together if you're multiplying. Now, what I want you to do, okay, and that's if you have the same base. So in this case, we have 2 is the same base. Here we have A is the same base. So if the base is the same and you're multiplying exponents, then you just add the exponents together. Now I want to make sure that you go into the Google Classroom, you get the notes that I put on there, and that you're writing along as we go through the notes. Okay? So if you look here, we got 1, 2, 3, 4, 5, 6, 7, and that's why we get 2 to the power of 7. All right? Okay, so now on the notes it said when you multiply terms with like bases. So when you multiply terms with like bases, so that is, we have like bases 2, or in this case we have A, okay? You add. Okay, you add the exponents. This is on your notes. Make sure to copy that down. The bases do not get multiplied. So we're not multiplying the bases. Okay, all we're doing is adding the exponents. Okay? So let's go through it. Here's a question. So y, okay, is 2 times 2 equal 4. Okay. Well, because 2 is 2 to the power of 1 times 2 to the power of 1, which equals 4. Okay? So 1 plus 1, okay, is 2, right? So that would be 2 squared. 2 squared equals 4. So I want you to pause the video and make sure you take these notes on the page I provide. We have some different examples of us adding, multiplying exponents, which we're just going to add the exponents. So right here we have 4 as our base, okay, and then we have 3 and 5 as our exponents. So we just add the exponents. So it's going to be, this is going to be 4 times 4 times 4 times 4 times 4. So we have that 3. Then we have 4 times 4 times 4 times 4. There's our 5. Okay, so if you add them all up, it's 8. I mean, you could just add them up, but I just wanted to do it. Only do it that time. So it's 4 to the power of 8 here. Okay, over here we have x is our base, and 8 and 6 are our exponents. So we're going to go x to the 14th power. We just add those exponents. Same base, add the exponents. Okay? Right here, we've got x is our base, but now we have a positive and a negative exponent. Okay, so we just add those together. 5 minus 7, which would be x to the 2. Now, this isn't the simplest form of this. Okay? Whenever you have a negative exponent, you just put what you're going to do is what you're going to do is this is over 1. Anything is over 1, basically. You know, any number is over 1, because if you divide anything by 1, it's itself. So to make this positive, we're actually going to put this on the bottom, okay, right here, x, and we're going to give it a positive exponent. Okay, so it'll be like this. This actually equals 1 over x squared. Okay, I'm going to do a couple more examples just so you see it, because we'll be doing this anytime. And when these problems get bigger, if you have a negative exponent on top, just put it on the bottom with a positive exponent. So on the bottom of the fraction. So for instance, if we have r to the negative 5, okay, that will just be 1 over r to the 5. Okay, if we have, and there's a reason for this. I mean, you get, you know, any number to the negative exponent that's less than 1. And so what happens is that becomes a fraction. Okay, anything less than 1 is a fraction. So that's what we can do. So if we have, you know, m to the negative 3, that'll be 1 over m to the positive 3. Okay, so you can kind of see what you do when you have a negative exponent. Okay, over here we've got 7, 2, and 1. Whenever you have just a singular, you know, just 1, there's no exponent, that literally means that it's got a positive 1 to it. Okay, so we've got 7 plus 2 plus 1. Okay, that's 10. So this would be y to the 10th. Okay, because you go 7 plus 2 plus 1. Keep that base. Okay. Over here, we got the last one. We've got a is your base, and then you got 9, 3, and negative 2. So we go 9 plus 3 minus 2. All right, 9 plus 3 is 12, minus 2 is 10. So that'll be a to the 10th power. Okay, moving on to the next section. Okay, if you follow along in your notes, when you multiply terms with like variables, okay, with like variables and coefficients other than 1. So remember, this is like a coefficient of 1 when you have coefficient, or when you have coefficients. So right here we have coefficients. These all have coefficients of 1, meaning, you know, that's 1x, that's 1x, that's 1y. But what happens if you have like 2y, 3y, 4y, those types of things? Well, we're going to get into that. So when you multiply terms with like variables, okay, so these are like variables, y, x. In this case, we have x, okay, and coefficients other than 1. So the coefficient is the number before the variable. Okay, so this is just 1y, so the coefficient is 1. This is 3x, okay, so the coefficient is 3. The coefficient here is 4. Okay, so you have a coefficient other than 1. What you do is you multiply the coefficients, okay, and then add the exponents of the like variables. All right, so right here, you're going to multiply the coefficients and add the exponents of the like variables. Okay, so in easier terms, we're going to make sure they have the same variable. That's the letter. So on your notes, that's what we're doing. Number 2, we multiply the coefficients. That's the big number. Okay, and then we add the exponents. The exponents is the little number. So here's an example right here. The first thing we do, okay, is we're going to make sure we have the same variable. That's the letter. Okay, number 1, we make sure it has the same variable. That's the letter. That's the same variable, x. Multiply the coefficients. 3 times 4 is 12. Okay, 12x. And then we add the exponents, the little number. So we have 2 and 3. So 2 plus 3 equals 12x to the 5th. Okay? Make sure to take those notes on the note paper I gave you. Then we're going to move on. Now we're going to do some examples of this. Let's simplify. Okay, we're just going to simplify this. So first, they have the same variable, a. Okay, then we're going to multiply the coefficients. Okay, So we've got 7 and 6. 7 times 6 is 42. 7 times negative 6 is negative 42. Okay, then we add the exponents. So you got the little numbers. 4 plus 5 is a to the 9th. So there we go. Negative 42, a to the 9th. Done. All right? Okay, so now we've got right here, I'm just going to, this would be negative 42, and then a 4 plus 5. Okay? And so that you kind of get an idea. All right, on this one, okay, we've got 9 times 3. They're the same variable, which is y. 9 times 3 is 27. Okay, and then y. And we've got negative 3 and 5. So negative 3 plus 5. All right? So we've got 27, y, negative 3 plus 5 is squared. And that's it. Boom. Done. Okay? And then the last one on this one is going to be negative 5 times 3. So negative 5 times 3 is negative 15. And then you've got k, and then k1 minus 4. So you got k 1 minus 4. Okay? And what's 1 minus 4? Negative 3. Okay? So then we've got negative 15 k to the negative 3. Now remember what I said. Whenever you have a base that has a negative exponent, you're going to put that on the bottom. So right here, this means over 1. Okay? So what we're going to do is we're going to take this k to the negative 3 and we're going to put it on the bottom. So we leave 15 on the top, and we just take that variable and its negative exponent, put it on the bottom, give it a positive exponent. Okay, so then what we get is negative 15 over k to the 3rd. And it's done. Okay, because you can't end with a negative exponent. You're going to want to end with a positive exponent. Okay? All right. So we're moving over here. Keep going on your notes. Okay? So just remember, if you have more than one variable, so in this case we got x, y, a, b, x, y, z. Okay, it might look confusing, but it's simple. Okay, when you have more than one variable in a multiplication problem, only add the powers of the like variables. So don't just add them all together. It's like. Okay, so we only add the variables of the x's, and then we add the variables of the y's. That's it. Okay, so we're going to go over this, and we'll see how it goes. All right, so we've got this one right here. Okay, first thing we're going to do is we're going to multiply 3 and 2, which is 6, right? And then we're going to go x, okay? We've got 2 plus 3. So we'll go 2 plus 3. And we'll go y, 5 plus 2. Okay, which equals 6, x to the 5th, y to the 7th. Done. Okay, 6x to the 5th, y to the 7th. So all we did was the like variables, x, 2 plus 3. The like variables, y, 5 plus 2. 2 plus 3 is 5. 5 plus 2 is 7. Done. Okay? The next one, we've got, really our coefficient is 1 over here and it's 2 over here. So 1 times 2 is 2. Okay, we've got x, 2 plus 1. Then we've got y, 1 plus 2. Okay, so that's going to equal 2, x to the 3rd, y to the 3rd. Done. Okay, there's that. Okay, now we're on to number 11. Getting a little bit more difficult. We've got 5 times negative 2 is our coefficient. So 5 times 2 is negative 10. Okay, and then we have a to the 6 plus 7. And then b to the 4, and there's no other b, so that's it. Okay, so then that's going to be negative 10, a to the 13, b to the 4. Done. Okay, and you might be confused about why I'm not putting 10 on the bottom, because that's just a coefficient. You only put something on the bottom if you have a negative exponent. That's it. Okay, right here we've got 2 times 5. Okay. So we got 10 x, you got x2 and x1, so 2 plus 1. You got y, 4 plus 4. Then we got z, 1 plus 3. Okay? So we add those all together. You got 10 x to the 3rd, y to the 8th, z to the fourth. Okay? All right? So there's your examples there. Make sure you take those notes down and every last part, and then pause the video if you have to and write those down. Okay, so 13 and 14 on the notes, application. The area of a rectangle can be found using the formula area equals length times width. Find the area of a rectangle whose sides measure 7x y to the fourth and 2x third y squared. Okay, same stuff. So you're just going to multiply length times width, so area equals this. So we're just going to multiply, remember the coefficients, so that's 7 times 2 is 14. Okay, and then we've got x 1 plus 3 and y 4 plus 2. Okay, we add those exponents up, so we got 14 x to the fourth, y to the sixth. Done. Okay, so we multiplied the coefficients, we got 14. We added the exponents of the variables, so we got x1 and x3. x1 plus 3 is 4, y4 plus 2 is 6. Done. Okay? Okay, over here, we've got a volume problem. Okay, the volume of a rectangular prism can be found by using the formula volume equals length times width times height. Okay, where L, W, and H represent the length, width, and height of the prism. Find the volume of the rectangular prism whose dimensions are 3a squared, 4a to the fifth, and 4a squared b squared. Okay, so the first thing we're going to do is multiply those coefficients, the numbers before the variable. So we got 3, 4, and 4. So 3 times 4 is 12. 12 times 4 is 48. Okay, and then we have a, and a. So we go a, 2 plus 5 plus 2. Okay, so we go 2 plus 5 plus 2. And then we've got b squared. All right? So now we have v equals 48, a to the ninth, b squared. There you go. Okay? I know my 9 kind of looks similar to my a, but it's different. It's different. All right? So that's that. So I want you to make sure you took all these notes. Ask any questions you need to. Check the Google Classroom for the worksheet. Get that worksheet done. We're just going to keep going. I'm going to keep putting these up, and hopefully you enjoy them and you learn as we go. So have a great day.